look at the clock speed. For example, for this computer 2.6 gigahertz for clock speed, and then for the RAM 16 gigabyte DDR4 for the RAM, and we also have here 12 megabyte of cache, and then for the storage we have 512 gigabyte for the SSD. Okay, so this is the spec, the hardware. So what is the main function of this hardware? Okay, the main function of this hardware, if you still remember the hardware, our first 4 topics is about hardware, is to execute, the function is to execute instructions. Okay. You should remember the cycle that we use. What and what cycle? Anyone? What is the cycle?
Fetch,
Execute.
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 Fetch, execute.
Decode, right? Good. And execute. Good. This means that you remember what we have learned so far. So the main function of the hardware is fetch decode, is to execute instruction by using fetch decode execute cycle. But which part in the computer system that controls this function? Okay, which part that control this function? So in today's class, we look at the part that control the machine or hardware, and this part is our 5th topic, which is operating system. Introduction. So today we look at introduction to operating system, and the following week we will look at all the details about the operating system. Okay. So today we will look at where is the location of OS in the computer system, the location. The second one, what is the definition of OS? So OS, it means the operating system. So what are the main function? We look at the main function of OS. And lastly, how is the structure of the OS? So in this topic, these are the books that you can read more about operating system, chapter 8, William Sterling, and also chapter 15. So you can, maybe this is the old version, you can find the newest version, but the newest version there is some, not only some slightly changed, but I recommend for you to find the new version. Try to see from the library, the PTSLs, is there any new version for this material? Okay. So first we look at the location of OS. Can you see where is the location of the OS? Level 1?
Yeah.
Level 3.
Level 3.
Yeah, good.
3.
Obviously, right? In level 3, you can find operating system, which is under system software. Okay. So in order the OS to control function of the hardware, the location of the OS, as you can see here, is in the middle of the modern computing system. Okay, so it is in the middle. So this is, you can say that the first part, and then this is the second part. And the middle, in the middle of the modern computing system, there is the operating system. Okay, next, which one is the right layer? Okay, this is A, start with assembly, followed by OS, and lastly ISA. and B start with ISA followed by OS and lastly assembly. So this one I would like to okay, I would like to the control. All right, I couldn't find. Okay, so which one is the right layer? A or B? Actually, I would like to call your name. Anyone want to get SS? Can you choose SS?
A.
A. Is it A? All of you agree with A?
Yes.
Yes.
Yes. Yes.
Yeah.
A, doctor, yes.
A. Eh?
I think it's
Yeah,
A.
doctor.
Okay, so if B, you don't get confused, means that the answer is A. Must start with the assembly followed by OS, and below the OS is the ISA. So this is the right and assembly. Okay. So the OS can control the machine. How the OS can control the machine? Based on the instructions carried out by the machine. Okay. So sorry for that. I need my pen back. Okay. So I would like to explain a little bit about this component. So OS can control, it can control the hardware or the machine based on the instructions that can be carried out by the machine that specified in the ISA. If you still remember ISA, instruction set architecture. So it has a set of architecture that show the ability of your computer. Okay. So therefore, OS is located on top of the ISA because it's control the machine based on the instructions that be defined in the ISA layer. And how about assembly? Okay, so OS need to control the hardware. So it's controlled based on the instruction that has been defined in the ISA. So above OS layer is the assembly. Then the assembly is near to the user. Okay. Then the OS. So the assembly contains this translation of the compiled higher level language. So as for example, the user made a program in Java, yeah, like your programming class, you did program in Java, and then this is in higher level language, and then you compile it, and the compilation will go to the assembly, and the assembly will translate that higher level language into assembly code, okay, or program. So the code and the program in the assembly language contain services required from the OS in order to execute the programs. So it means that as a user, let's say you write a Java program, you want to save data in a file, for examples, okay? Or you want to print out the date of today, print out or display the date. So you write the program.java and then you compile your program, it's become a dot out. And then what happens when you go to the assembly level, it will translate into the out into assembly code in the new language, which is in assembly language. And in this code is actually contains services or tasks that required from the OS in order the OS to run the programs. So what the US do is that based on this code, it will ask the services from the machine. And the machine will fulfill the request from the OS. Okay, so I will explain one more time. As a user, you write a program in Java, which is a higher level language. And then what happens is that when you compile it, it will become into the execution file, a compilation file. And then it will be translated into assembly program. In the assembly programs, actually it contains code that reflect the services that you need from the OS. So how the OS can make the services available to the users, it will request it from the below, from the ISA and below. So this is how the flow between the assembly, OS, and ISA. Okay. So where is the location of the OS? So therefore, OS is act as a, what do you think? So OS is act as
Intermediate.
yeah, inter intermediary between the users and user program and the hardware of the computer. So this is your OS. Okay, so it is like the middleman between the users and users made application programs or any available program that a users has installed, and then based on that programs you will request from the hardware, it will control the hardware to fulfill the need of the user. So from this, what are the important components that define OS? So we can see that OS in the middle now, okay, between the top layer, which is consists of assembly language, higher level language, and users, and then the bottom one, which is consists of ISA and gate and machine level. So what is the definition of OS? Okay, so we can see that OS is actually what? What do you think OS? It's a collection of what?
Software.
Okay, good.
Programs.
Computer program.
Computer programs.
Operating system.
Okay. So actually, when we talk about operating system, it consists of many programs that has been developed by developer for the operating system. Okay. For what? For what? It is to control the hardware. Talk about what is operating system, we can say that operating system is a collection of computer program. We can call it a software, but it's more specific programs of computer programs that integrates the hardware resources. Okay, so this is the hardware part of the computer and make those resources available to a user and the user's program. Okay, so because without operating system, we cannot use the hardware. So our hardware is useless. That's why we need the middleman here, the middle between the users and the computer hardware, which is the operating system programs, so that the resources is available to user and user program in a way that allows the user access to the computer in a productive, timely, and efficient manner. So it means that when we talk about operating system, we would like programs that can help the users to control the machines in order the users to get back the results that they want. If they ask the computer to calculate, to use the calculator, so the computer will calculate for you. So this is the definition of hardware. Sorry, the definition of an operating system. So now we have known that the operating system is a collection of computer programs that integrate hardware resources and then make those resources available to the users. And also you would like the users access to the computer in a productive, timely, and efficient manner. So to be specific, what is the main function of the OS? So we can define here the OS actually to provide two things. The first one is the convenience. The second one is efficiency. We look at the first one, convenience. Okay. Oh, sorry. The first keyword to make a computer more convenient to use. The first keyword that reflect the main function is convenience. Okay. So why we would like to say convenience? Because OS will provide a suitable interface for a user to do any task related to a computer. So between Windows and Linux, which one is more convenient for you?
Windows.
Linux?
Windows.
Anyone like Linux? No?
Mac.
Mac? Oh,
This guy.
okay. So because because you find Windows is more convenient. Maybe because of the user interface. The UI.
Because it is most common software.
Mm-hmm.
User friendly.
Common software. And then what else? User friendly. How about
Supports a
Linux?
lot of software.
Yeah, common software and a lot of software, especially games, right? That you
Yes.
can
Yeah.
install and any software that you need to use to be used in your lectures, in your study. Okay, so OS also provide a convenience because it makes you because the software, the OS will help you to run your program. Okay, and then what else the OS will do? The OS will also control the input and output devices. And lastly, when the program has error, it will also detect the error and let you know the error so that you can make any response, suitable response. In the end, the OS can also act as an accountant. Okay, it can collect usage statistics for various resources, and also for you to monitor performance can use as you can see here in Windows Task Manager. So yeah, can you try to open your Windows Task Manager now?
Yeah.
Okay, doctor.
Okay, so we open together. Okay, I also open here in my computer. Is it control alternate delete, right?
Yes.
Yes.
Alright. So this is my window task manager. So okay, any one of you want to share your I would like to get someone to share their Windows Task Manager. Okay, maybe Haikal Iman, are you there?
Yes, doctor.
Can you share your screen so all of us can see your Windows Task Manager?
Okay. Boleh nampak tak?
Nampak
Boleh.
ni.
Nampak,
Yes.
nampak.
Okay, so what you can see from here, Haikal? Your task manager.
The CPU speed.
What else?
What else? This one, memory speed and GPU.
Okay. So can you see from here, can you see that the computer can be accountant? I mean that they show the statistic of your system, right?
Yes.
Yes.
Okay. Next cycle, can you open the resource monitor there? Okay. So this is the resource monitor. So just now, what the Haikal showed us that the OS can also act as an accountant. Okay, you can collect the OS can collect usage statistics for various resources. You can monitor the performance as you can be seen in the Windows Task Manager. So now we'll look at the resource monitor. Okay. So can you click on CPU, Haikal? Okay. So this is the tab for the CPU. So from the CPU tab, actually you can see that how much time the CPU is allocated to execute the program. So how many programs that okay, there are some programs are running there. So PID is the process ID. So I can see whether you open games or not, right? You are not open any games. Okay, that's good.
I'm
So
focused.
you're focused in class. Good.
Yes.
So you can see that average CPU. So we can see how much time the CPU can allocate to execute the program. And then can you go to memory tab? I can. Okay, so this is the memory tab. So the OS was actually the one that allocates how many portion of the memory for each of the program and data from the users. Okay, the OS that do that in your computer. Okay, and then next this. Okay, so this is the memory. Okay, this is the disk, the storage. So our OS also control the access to files in storage and also the input output devices. So this is from your resource monitor. So you can see how the OS actually monitor the and control, actually is also control the resources which is the hardware part, CPU, memory, disk, and network in your computer. Okay, thank you. Thank you very much, Haikal. Okay, so thank you, Haikal, for sharing the resource monitor just now. So I will share back my slide just now. Okay, so this is mine. So there are many things that you can learn from here. Cache, there are 3 level of cache here. How many cores, 2 cores, and then the utilizations, processes. So what is the process? Process is program in execution. Okay, any programs that you run, it will become process. So if you look here, these are the programs that are running now. Okay, so in okay, this is all the resources. Okay, so the most important part is that the our OS, the first one, it is very convenient for you to use. Okay, it has user interface. You just click in order to run a program, to install a program. It's just minimum input from the users for installations, and also it's also efficient because it helps the users to control all the resources. So can you see that who did actually this one? The percentage is different from time to time. You can see that how actually the OS is now controlling our computer. Manage the CPU, manage the memory, manage the disk, the network, the GPU. So our OS now is trying to make the computer system become convenient and also become efficient. Okay, so I continue back our slide. First one is convenience, and the second one is efficiency, like I explained before. Okay, so far, any questions about operating system? Is it clear the function of the operating system? Yes.
Okay, Doctor.
Okay.
Okay, Doctor.
As of
I will
now,
proceed.
okay.
Okay, so it's just the santai time. But I think I will proceed first with others and then I will continue back to that. Is it okay? So I think I will go back to that one, the santai one, because I would like to focus on this important part. You want to have break now?
Yes.
Boleh.
Yes.
So in that case,
Sure.
I will do this first. So before we break, I really like to share to you with this the information that I got actually from my teacher, my matriculation teacher. So for your information, I did my matric here in UKM, and we call it as Campus Indo. So my mathematics teacher said that within 24 hours, you have to do the revision. You have to revise back the materials that you have learned in the class. So So during my time, I try my best in UKM because I did my degree, undergraduate and master in UKM in FTSM. So I try to implement this technique. What is this technique? Is that let's say today class at 4 p.m. and end at 6 p.m. So if you immediately after class, maybe after Asar prayer, you look into the materials again. So if we see that the percentage of what you remember in class will go up again. Okay. So within 24 hours, uh, if you revise back, uh, you will remember that again. So imagine that you has not do any revision until the exam. So it means that you may remember anything. You will not get any under what you have learned so far in the class. You might not remember all the things. Okay, so I would like to suggest for all of you, if there's lecturers give you homeworks, actually that is the best time for you to revise back the things, the lecture notes that you have learned in the class. Okay, so that is my tips for smart study, because in higher level education you need to do smart study. All right, we have a break for 10 minutes. So we continue back after 10 minutes. So during that time, I will share again the QR code, and then we'll focus on the structure of OS after this. Okay, so we have a break now, 10 minutes. So until 4:55. Okay.
Thank you, Doctor.
All right.
Um,
Yes. You want to ask question?
Your mic is near.
okay. Doctor, I want to ask you about the discussion group.
Oh, just now.
Yes.
Okay. Um, let me check. Can this one? Oh, okay. Okay, I try to open the UKM folio. If you okay now. Sorry. Yeah. I think the UKM folio is still not okay. Or you have any friends that you can just join them and let me know.
Okay, doctor, I will let you know. Thank you, doctor.
All right. Okay, can we continue our class?
Yes.
Yes.
Okay.
Alright, so now we have come to the fourth subtopic, which is how is the structure of OS. Okay, we would like to look at what are components that form the structure of an OS. Oh, sorry, this one is recorded, right? Lecture? Okay.
Yes.
Okay, good. Sometimes I forgot to do that. Thank you for recording this one. Okay. So we look at the structure. So basically the structure of computer system. So this is a computer system. So I would like to draw something here. Okay. So in a computer system is divided into two, which is software, and the bottom here is hardware. Okay. So this is a computer system, and actually another component is data. So computer system is consists of data, software, and hardware. Okay, we would like to see in the software area. So what inside the software area? There are two main areas in this software. Okay, so I would like to divide this area into two. This is the first one, and then this is the second one. So the first area, we call it as user space. And the second area, we call it as kernel space. You know kernel? Con. This is in the middle of the con. So here is actually the core of the software. We call it as kernel space. Okay. Inside the user space, what inside the user space? There are two important components there. The first part is application program. So this is what the users usually use. Okay, Microsoft Word, Excel, your Eclipse, or any programming tools. And then the first one is the application program. And the second one is system program. System program. So these are the two components that you can find in the user space. So what are the components inside your kernel space? So in the kernel space, which is the important part, it has operating system services. Okay. Services. So what are the important services offered by the kernel space, offered by the OS? The first one is, when we talk about program, when a program is in execution phase, okay, when I just want to show you, when there is a program here, then you execute the program, the program, we call it as process, okay? Like what Haikal showed us before, the one that has PID just now, which is process ID, is actually refer to process. So the service here, the OS service, they has process management. Okay, so the OS act like a process manager to manage all the processes inside the computer. Okay, so the first one is process management. So, and every program here and data that need to be executed by a processor need to be loaded in main memory. So remember, so every time the CPU want to execute the program, let's say this is the CPU, this program must be loaded first into the main memory, which is the RAM. Okay. So there will be an OS, which is memory manager, memory management, memory manager that make sure that the program and data has been loaded into the main memory. Loaded from where? From the secondary storage. Secondary storage. So the memory management must make sure that all the programs needed by the CPU to be run must be loaded first into the RAM, and then the CPU can fetch the instructions to execute the program. So that is the second component of the kernel space, which is memory management. The third one, so in your computer, you can also find file. So what is file? File is a collection of related information. Okay, the file has structure, name. So in your computer, you very familiar with files. Okay, you have files name. Like me, I like to, if I have something, I like to write with date. For example, 10 of 11, 2020, and then the version 1, version 2. Okay, it depends on you how you make how you organize your files. Like me, I will organize based on my KPI. Okay, I have folder for my teaching materials. I have folders for my research. I have folder for my services. So for example, in my teaching, I will have platform technology. I also the coordinator for project for PM for IT students. So this is how I organize my folder inside my computer. So this inside the folder, there are many files inside the folders. Okay, so this file has the name, have the extension. For example, my PowerPoint will be .ppt. So we recognize the file based on the extension and so on. So that is an important part in the OS that manage the file. We call it as file system management. So that is a manager, file manager that will manage all the files inside your computer. Okay, lastly, still remember that also deal with the input output, okay, like the printer, you have mouse, monitor, okay. So all of this need to be managed as well, and they will be the fourth component inside your kernel space, which is input, output, management. Okay, so we can see here, this is the structure of the computer. Computer system consists of hardware and software. So inside the software, we have two parts, user space, and another part is kernel space. So inside this kernel space, we have programs that being used by the users. We call it as application program, and also programs that utilities programs just now, like the Windows Task Manager, Resource Monitor, program that supports the running of the system. We call it the system program. And then another part of the software, which is kernel space. And in the kernel space is actually the part, the area for the OS to provide their services. So they can give services in terms of the process management, memory management, file system management, and input-output management. Okay, so any question for this structure of OS? Is it clear?
Clear.
Yes, Doctor.
Clear.
Clear.
Doctor, I'm quite
Okay,
lost when you
so
were explaining process management and memory management.
Me too,
oh,
doctor.
don't worry. Memory management. All right. So don't worry. Topic 5, 6, 7. Topic 7, there is a special topic only for memory management. Okay.
Oh,
So
okay.
what I said before this, what I talk about that the program need to be loaded first into the RAM, and where is the location of the program is actually from the secondary storage. So all of this will be explained in detail in topic 7, memory management. Is it okay?
Okay, Doctor. What
Okay.
about process management?
Yeah. Next topic.
Oh,
Next week.
okay.
This process management. The 7th one will be memory management. Okay.
Okay.
All right. So basically memory management is very important part. So like your friend asked just now, I just give some quick information. So we call it permanent storage, which is your hard disk. Okay, when you install any programs in your computer, all the execution file is actually stored in your hard disk. If you have 112 gigabyte of RAM, this is your permanent secondary storage. So what happened when you double click the program, when you want to run the program, this will be loaded first into the RAM. So every time you run the program, actually what happened is that the program will be loaded first into the RAM. So that's why when you open a big program, a big application, it takes time for you to load. The loading time is sometimes it takes application and another applications. It's based on the size of the program. And if your permanent storage or your storage, your hard disk is very slow, it will take more loading times here. The next, it will be cached by the CPU. So we will learn more about how the OS manage the memory in the 7 topics, which is memory management. Okay. So now to another component inside the OS. Okay. So before this, we look at in the OS divide by user space and the kernel space. Okay. So how to connect between these two? Between the user space and the kernel space. So how to connect between these two areas? So users areas and kernel areas are connected by, what happened here? Hang. Sorry for that. I close? Wait. Okay, I just open it back. Okay, what do you think? How to access the services provided by the OS? By using?
System call.
System call.
Yeah, good. Dah pandai dah ni. So I open back my okay. So can you see my slide now?
Yes, doctor.
Yes.
Okay, good.
Yes, doctor.
All right, good. So
Doktor,
yeah,
doktor. Kerana space ni, dia under user space ke ataupun ada berasingan? Sebab kalau yang dekat dalam AD puzzle tu kan dia dalam bulatan, user space kat luar, kena space kat dalam.
dia dalam ni macam ni
Ah,
So ni kenal kan? Dia kena space
The core
and
OS.
then the user space. Yeah. So we can say that this is inside software.
Software. Oh,
So from the software part, if you are a user, if you want to get the services, you go through like this, right? So this is the outer layer. It's like a layer. Okay. If you are a user here, you want to get the services, you have to go through the user space first, and then you come to the core of the software, which is the kernel.
oh,
Okay, can you get that?
faham. That's, yes. Thank you.
Okay, they are separate. Okay, they are separate. So if the user space would like to connect with the kernel space, they need to have a special function here. We call it a system call. Okay. So what is system call? Okay, for example here. So between this and this, so in the middle here, we call it a system call. Okay, is it clear?
Yes.
Okay, good. So
Yes.
you system call. So what is system call? So when we talk about OS, when we talk about something related to OS, it actually is programs. It's actually a program. Okay. One system call that for one program, for one system call, there is a related program. So I will show you examples. So programming interface to the services provided by the OS. So it means that if you want to access to the services, you need to use the system call. So typically written in a high level language. So if you would like to see what inside the system call, you can try to search more in Linux environment, because Linux is open OS, open operating system, where you can see the code for the operating system. So for this class, we don't go into details the code inside the OS. I think there will be another course. Not all students will take the course, the operating system course. Okay, maybe in second year. Okay, I give you examples. Let's say you have system called. Okay, any of you has opened your Linux now? Maybe any of you has opened? Any volunteer to open Linux? Or maybe I just it's okay then. I just proceed with the explanation. So before I proceed, any of you have problems with Linux, please let the instructor know or let me know also. Because I will give names to the head of the IT in FTSM, so we can try to make try to find solutions. Maybe we try to set up VPN, virtual private network, for you to access the Linux. So please, as soon as possible, if you have any problems with the Linux installations, if you cannot use the Linux to do the lab assignments, please let us know. Okay, let the instructor know, message them, and it's better for me to know also. Okay. Okay. You can try after this. You can open your terminal for shell. For the terminal, if you open your terminal, actually when you enter the command, the one that actually translate your command, that interpret your command, for example, you make a directory, you make deal, right? You want to change the directory, you make the change, you want to create the file or so on, you make, this is actually system call. And when you enter in your terminal, the terminal itself has a program that interpret your command. So this command interpreter, we call it as shell. Okay. So in Linux we call it as shell. So for example, you type command date in the terminal. What is actually happened? So let imagine that you open your Linux and then you type the command date in your terminal.
Madam dah buka.
Huh?
Doktor dah buka. Ada yang dah buka.
Oh, ada yang nak share screen? Any volunteers?
Panggil je nama yang dah buka doktor. Macam kat chatbox tu ada Muhammad Syami. Panggil je dia.
Awak nak suggest siapa? Muhammad? Saya
Syahmi.
tak buka
Sebab
chatbox.
Muhammad Syahmi. Dia kata saya dah buka Linux.
Boleh you can share?
Saya sokong doktor.
Can you share your screen? Syahmi, right?
Hello?
Hello?
Itu saya.
Syahmi boleh share ke? Can you share your screen?
Saya dah share kot. Sekejap.
Dah share? Oh, okay.
Dah nampak.
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 Okay, good. To have error with date?
Sorry?
Okay. Kalau, can you type just date? DATE only? Okay. So, can you see that what happened actually? Syahmi install di mana ni? VirtualBox ke? Oh,
Oracle.
Okay. So, how about labs? Okay semua?
Maksudnya?
Lab semua okay? Lab 2 dah? Have you done your lab 2? Lab 3, sorry, lab 3.
Lab 3, no.
Not yet.
Belum.
Not yet.
So now Syahmi has typed date, right? So what is the response from the system now? Syahmi? What the system give you?
The date and the time. The time. Yes.
Okay. Okay, good. So when Syahmi type date, okay. So what is actually happen is that Syahmi actually be a user. So Syahmi requests the date into the system. So what happened in the system? The system need to know the date of the operating system, right? In the Linux date. If you set the date right, so you will get the correct date, right? So what happened is that when Syahmi type date, it will do some requests to the kernel space. Okay. So I just want you to imagine what happened now. Okay, when Syahmi type date, just come out with the results, right? Selasa 10 November, just come out the results. But behind that is actually a 4 steps happen there. The first step is that Syahmi request the command date. So it means that Syahmi type date. Okay. And then what happened behind it is that the second step, it will be trap instructions. I will explain later, but I just explain based on Syahmi's Linux terminal. So what happened before we can get the results, there is a switch from the user mode to the kernel mode. Okay, before we can get the date, there must be a switch control from the user mode to the kernel mode. And this instruction, we call it as trap instruction. So to switch from the user mode to the kernel mode, the trap instruction will be executed. And what happened in the kernel mode? Actually, in the Syahmi's PC, when Syahmi has installed Linux, all the programs related to the commands has also been installed in the kernel space. Okay, in the kernel space inside the memory. In the memory RAM, there is a spacious place allocation for the kernel. Okay, so when every time you install, not every time, when you install an OS, in the RAM there will be a special place for your kernel. So what happened here is that the program for date has been executed by the kernel, and then the fourth step is that the users get back the results, and the control is returned back to the users, and the users can type more and more commands to the terminals. So you can see here this terminal, when you type date, there is actually a special software that translates that date. We call it as shell. Okay, can you type $sign? I don't remember the code, but I try. Try Syahmi. $sign, share, $sign. Can you type $sign? Okay. Can you enter? Okay. I don't remember
$sign shell.
I don't remember the exact command. To know to anyone remember to identify the version of the command interpreter, the version of the shell. Anyone want to help here? Ada ingat tak?
Saya tak ingat.
Okay, tak apa. We will explore more after this. Okay, try. Saya lupa dah. Hari tu pernah cuba. Nanti bila if I remember back, I will share with you. Okay. So as far as I know that that one bash. The bash is actually the command interpreter for for this terminal. Okay, thank you very much. Dah pandai dah Syahmi ni. So bin bash means that the location of the bash system. Okay, good. Syahmi show us good examples. We can see that the programs for the command interpreter is located in the folder named bin. Bin stands for binary. Okay, so all the execution files in the Linux is located in bin. So if you want to find the execution file of the programs that be running in your Linux, you can find in binary folder bin. Okay, thank you very much, Syahmi, for sharing your screen. Okay.
Right, thank you, Doctor.
Okay, thank you. So I will continue with the explanation just now, the details of the. Okay. So just now, what the Xiaomi has typed. So this is a users. So Xiaomi type date, right? So just type in Linux, you just type date. So what happened is that the user requests to get the date of the system. Okay, so to process the user request, there will be some special instruction. This instruction, we call it as trap instruction. So in the trap instruction, we would like to switch the control. Okay, we would like to switch the control from the user mode to the kernel mode. Okay, so that is the second step. The trap instruction will be executed to switch the control from the user mode into the kernel mode. Okay, what happens next? The system call number for the request will be identified. So the request is date. So like I said before, all the programs for the system call will be located in the kernel space inside your memory. So when the users want to find the date, what happened in the kernel space, it will find where is the location for the command, the location of the program inside the kernel space. Okay, let's say the number is I, the index for the program is I. So based on this number, the system call handler will run the program. So what happens next is the implementation. The implementation for date. Okay, where we have identified the number of the system call, the system call handler will execute the command. So the command will be executed. Okay, so last step, the fourth steps, when it's finished, it will return the control back to the user. So when it's finished, you will go back into your user, and what the user get here, for example, Shami just now, he get the date, which is Tuesday, 10 November. Okay, so this is how the system call works inside your computer. Okay, any question about this? Is it clear?
Excuse me, Doctor.
Yes.
Can you recall this one more time, like a bit short? I'm quite confused.
Okay, so I will explain it again, right? So I start with the first step. Okay, the first step, the user requests command date. Okay, so this is the users. What the users do is that the users type the date in the terminal just now, like what Syahmi do. This means that at that time the user requests command date. The command is date, and that is the request from the users. So what happened is that the OS need to execute the command. So it needs to get access to the kernel space, because the command, to execute the command, only the kernel space can execute the command. Okay, so we need to get to the user space. So behind it, we don't see what happened inside the OS. It actually, before you can get the result, is actually run this special program. We call it as trap instruction. So what happened is that the OS now switch the mode from the user mode into the kernel mode when it runs trap instruction. Is it clear until here?
Yes.
Right?
Yes,
Okay.
Doctor.
So trap instruction is to switch the control between the user mode and the kernel mode, because the user mode there is no privilege to get access to the kernel space. It needs kernel to be kernel mode in order to get access to the kernel space, because kernel space is privileged. It needs special instructions to switch the control, which is from the user mode and the kernel mode. So what happened next is that in the kernel mode, we need to identify the number for the system call, because there is a lot of system call. Okay, this is, for example, here there is a system call, a set of system call here. There is a lot of system call in the kernel space. So which one to be run is based on the number of the system call, because the system recognized based on number. So for example here, the number for date is I. Okay. So the third step is the implementation of the system call. It means that the system call handler, so I write here, system call handler, the one that handle the request for the system call. So there is a special program here called system call handler. The system call handler will execute the program, will implement the program for the system call date. So the system call handler will execute this command. Okay, so what inside this is actually a program. I here is actually a steps, a list of instructions, a programs. So in order to the user get the results, the system call handler will run this program, the program for date, the system call for date. So next, after the implementation, the control must be written back to the users. Okay, so what happened after completing the execution, the control is written back to the users so that the users can get the results. The results will be displayed, in this case, in the terminal. In our case just now, this is the results for the command date. Okay, so is it okay?
So far, so good, Doctor.
Okay, so that's good because this is all about system call, and now I proceed to show you some examples for system call. Okay, so can you if you see that under process management, that I say there is a lot of system calls inside operating system. So these are the function, the system call, or we call it as function. And this is the output of the system call. For example, if you type fork, you get PID, which is the process ID for the process. And also here, I think you will use it in your lab, is to get the ID of the process, get PID, and the results is PID. And there are other examples here, for example, exit. So this is signals. So the one that we usually use here is kill, to kill the process. So send a signal a process. For example, if you want to kill, you can send the signal to kill the process. So this example for signals. These are examples for directory and file management. I think in your lab you have done this one, MacDir, which is to create a new directory. So there are others examples of command here, system call. Okay, I did go to a workshop for Linux. Okay, beginners and also advanced Linux. So the instructor there told me that if you want to become experts in Linux, try to learn one command every day. Okay, for example, here, if any of you want to become experts in using Linux, okay, then you can try to follow his advice, which is try to learn one system call, one function every day. So in 1 year, you get a lot of, you will know more and more system calls. Okay. Okay. So that is all for today. So as a summary, I would like to say that the OS help us to operate the machine, the hardware that we have, because the OS has the program to manage the CPU. Okay, because the OS has the program to manage the CPU, which is the process management. Okay, and the OS help us to manage the memory, which is the memory management. The OS help us to manage the file with the file management system. The OS also help us to control the input-output devices, which is input-output management. Okay, so as a homework, I would like to ask you guys discuss within 10 minutes maybe. Ask your group what OS your group will choose to operate this machine. For example, this is your machine. What OS that you will select? Okay, I think you might want to choose Windows, but before you choose Windows, please find information about Linux. Okay, because I just want to share my students he went to LI practical in a company, I think TM. So he needs to develop a software AI. He was from multimedia program, and when he did his practical, he did something related to AI, which is quite good for him, and he likes to learn new things. So the environment that he used is Linux. Okay, so that's why it is very important for you to open your knowledge. Not only you know the Windows environment, please use this platform technology course for you to become expert in Linux. Because in the future, you might want to use the software which is only available for Linux environments. Okay, because I taught HPC, high performance computing, for master degree before. So for teaching that course, I need to use Linux to show them examples to cluster a number of computers, which is only free for Linux environment. If you want to make a cluster of computer, you have to pay to buy programs to do that in Windows. But in Linux, there are some programs that is open source program, which is free for you to use. So take this opportunity to learn Linux so that you have a lot of opportunities in the future. And lastly, the second question is what are courses for this area? So there are two questions here, very, very simple questions. I think you can finish the group discussion within 10 to 15 minutes. Okay? All right, so any question about homework?
No.
Okay, is it clear, right? Okay. So I would like to have quizzes because before this we have problems with Kahoot. But before do the quiz, I really want to know these things. Okay, this is I just want to know your how the Kahoot, how the Go Formative, how the ED puzzles actually give impact to your learning as higher education students. So I really want to know the impact so that we can improve more about set up the learning environments for you. Can you do it now, please? I will share the before we go to quizzes, I will share the link here. Okay. Let me share the link in the okay. Okay, can you open it now, please? Okay. So can we do it together now? I also want to do. Can you please do it now? Is it okay?
Doctor, is it the Google Forms you sent in the other chat? Because we need permission.
This one you cannot view?
Yeah, oh wait, hold on. Never mind.
Use your siswa email.
Yeah, I forgot to switch accounts again. Never mind.
Is it okay now?
Hold on, it should be okay now. Yeah, it's okay now. Never mind.
Okay. So 5 minutes only. Maybe less than 5 minutes. Do it. Okay. So rewards. Do you like to get rewarded during learning? Okay. Yeah. Before this in my class, I give rewards. Like pen drive. But now it's quite limited. Okay, it's better for me to see my success. With more invention, I'm go rewarded for it. This is about reward. Okay, is it important for you to get reward during the learning process? I would like to know. The more I know, I will get something for it, something materialistic. I don't know. Is it? I'm willing to change myself if I get rewarded. Okay, if maybe yes, rewards motivated here. Yes, of course. Okay, next competition. Do you like competitions? Yeah, I like competitions. Quiz. Participate in quiz. I really like to go for quiz. Ambitious and other around me. Ambitious. I like to see us the result. Yeah, agree. Important for me to better. don't really agree about that. I like competitive learning. Strongly agree. Alright, social comparison with others. Do you like to compare? I don't like to compare. To compare, yeah, in terms of education, in terms of feel more safe. I know what they're doing, so I can feel more okay. I also want to know what others do. What else? Important. You said so many questions here. Oh my god. It's a lot of questions, right? You want to
Yes,
continue
doctor,
after
a
this?
lot.
Yes, doctor. So
Maybe you
many.
continue after this, right?
We take 30 minutes, doctor.
30
Yeah,
minutes.
around 40
Okay, so
questions.
okay. In that case,
I think
can you do it after this? Maybe tomorrow or today after the class. Is it okay?
okay, doctor.
I hope all of you do that. Just continue after this. So now, yeah. I need to. Sorry.
Hello.
Oh my god.
Professor?
Yes.
Hello. Yeah. I I checked on the link.
Is it not possible?
He says he clicked on the link, then it says he need permission to access the link.
Oh, so how to solve it just now?
Use you can
Use siswa email.
Oh, you need to sign in using UKM email, right?
Yes.
Okay. So you need to use your UKM email first. You sign in UKM Siswa. You have that email, right? Siswa UKM. So you just use that email. Okay. So now last we have a short quiz. Okay. So can you please join the quizzes?
Minute.
Okay, sambil-sambil Hah?
Doktor nak tanya. Nak tanya jap. Kan kalau contohnya satu software tu dia ada satu kernel je kan. So kalau kat dalam laptop kita ni sekarang kita guna VirtualBox. So kita ada line up dengan dua. So maksudnya kita ada dua kernel ke?
Dalam VirtualBox tu dia OS dia akan dikenal. Betul lah. Every OS must have kernel. Because the kernel consists all the services offered by the OS. But in VirtualBox it's special, right? Because it's like having a different machine in your computer. It's like you having two machines.
Oh, maksudnya yang VirtualBox. Oh, maksudnya kernel box untuk virtual machine tu dia cuma virtual je lah.
So VirtualBox actually you create a virtual machine inside your computer. It's like you can create a number of machine, right? In VirtualBox you can have 2 or 3 machine actually in your VirtualBox. So every time you set a virtual machine there, you actually create a new environment. So that's why for that virtual machine it has the kernel for Linux. So the Linux kernel is inside that virtual machine, But to run the virtual machine, you need the environment Windows because it's installed in Windows, right? Did you get me?
Yes, I get. So basically main kernel kita guna Windows, lepas tu virtual machine tu guna kernel punya Windows, and then lainnya ni cuma virtual dan guna virtual machine tu saja. Okay, thank you.
Yes, that's correct. This means that when you install VirtualBox, you create a virtual machine. So there is another virtual machine actually inside your computer, and virtually you install another OS inside the virtual machine. So if you install an OS, eventually it will be kernel inside that environment. So for that particular virtual machine, there will be the kernel space for the Linux. Okay. So all inside the quiz now. Can we start now?
Wait, doctor, not in yet. Line slow.
Line slow, eh?
Yeah, doctor, wait, doctor.
It's not so many questions. It's only have eight or 7 questions. Okay, maybe
Wait, doctor. Wait, doctor, wait.
All right. Okay. Now. Okay, I think 1 more minute and then I will start. Five 55. I will start. Okay. Hujan ke? Kat tempat masing-masing hujan ke? Is it raining?
No. Nope. Macam
No.
Dah berhenti.
Not here.
Air tak ada.
Selangor.
Selangor tak ada air.
Selangor.
Tak ada air lagi? Aduh. Si baiklah saya dah pindah.
Setiap bulan tak ada air, doktor.
Ha?
Setiap bulan tak ada air.
Selangor tak ada air nak hujan, doktor.
Tak ada hujan je lah.
Okay. We just start Kalau yang lambat tu just enter the code. Alright. So just enter the code. You still can join it. Alright. The code is here. If problem you can
Doktor, ada seorang kawan saya ni dia tak boleh masuk sebab tak ada internet dia ada problem.
Nanti aku jadikan dia home lah, home. Ingatkan saya remind me. So,
Alright, doktor.
kita nanti I will just remind me that when to in this one, I will make it as like just like okay. So can we stop now? For you. So you can try again after this. So I just stop here now and you will try again. You try it again when I ramainya ni. Tahniah so don't worry if you want to try again, I will make it as a homework. If you don't finish today, because this is just for fun, so for us to try the knowledge that we have during the class. Okay, this is already 6 o'clock. Thank you all for coming. So, but lastly, before we end, just remind you to do this. This